Alright, at the end of the last video about graphing quadratic functions, I forgot that I was going to show you the alternative way of graphing y equals x squared plus 4x. So, on the last video, I actually factored x squared plus 4x and I found x-intercepts and I went from there. So, the other way to do this is actually go ahead and find the x-coordinate of the vertex. Right off the bat, and the formula for that is a very important one to know, is the x-coordinate is negative b over 2a. Alright, in a quadratic equation, quadratic function in descending order, the b is just the coefficient in front of the x term, so the b is a positive 4, and the a is the coefficient in front of the x squared term, which is a 1. It's understood 1. So when we substitute in, we get a negative 4 over 2 times 1, negative 4 over 2, which is negative 2. So that's the x-coordinate of the vertex. So over on the x-axis, that's where negative 2 is at. So I then have to plug in negative 2 into the original function. So the function of y equals x squared plus 4x. I have to plug in negative 2 in both places, put your negative 2 in parentheses, plus 4 times negative 2. I have to put negative 2 in both places for x. So y, the negative 2 squared is a positive 4. 4 times negative 2 is a negative 8. So 4 take away 8, that's a negative 4. So negative 4 is the y coordinate of the vertex. So negative 2, negative 4 is the vertex. So I can start from the origin, go left 2 and down 4. So that's my point of the vertex. Alright, and a very handy technique, instead of substituting a bunch of numbers in, when your function like this one starts with just an x squared, alright, if you have the vertex, to speed you up, you just go right 1, up 1, then go left 1, up 1 from the vertex. So from the vertex, right 1, up 1, and put a point right there. Go back to vertex, left 1, up 1. Alright, you got 2 more points. Okay, continuing on, when you go right 2, 2 squared is 4, you're going to go up 4. Okay, or go left 2 and up 4. Okay, so from the vertex right 2, up 4 puts your point at 0, 0. From the vertex left 2 and up 4 puts your point at negative 4, 0. So you got 2 more points. And there's actually enough room on this graph to put 2 more points. So you can keep going. And if you go right 3, 3 squared is 9, you're going to go up 9. You could also go left 3 and also go up 9. So in your vertex, when you go right 3 and up 9, you get a point at 1, 5, and it's always, it's always symmetric. So here's another point. So you can get a really good graph of this function. Alright, the characteristics would be like if you watch the last video, the domain is all real numbers. Okay, the range. The vertex, always start from the vertex. The vertex actually goes over the y-axis at negative 4. And that's the lowest that U-shape is. So the lowest the graph goes is negative 4. Put a bracket there. It reaches negative 4. Goes up forever from there. Alright, the interval of increase. Alright, again, go back to the x-axis from the vertex. Go up to the x-axis. Okay, so it starts at negative 2. The increase starts at negative 2. Okay, so from negative 2 to infinity, always a parenthesis there, because at the vertex, the graph is not increasing or decreasing. Interval of decrease starts at negative infinity until it reaches negative 2. X-intercepts, this has 2 in this case. There's one of them is at -4 and x equals 0. The y-intercept is where it crosses the y-axis at y equals 0. The right-hand behavior, as the graph moves to the right, the y values get higher and higher. As you go to the left, also y values increase. So as I was thinking about this after the last video, I realized I haven't done any graphs, or at least I don't remember, where it doesn't have any x-intercepts. And here's another technique. If I want to graph the function y equals x squared plus 6x plus 10, well, that's a trinomial, so I can't factor using common factors. I can use a formula x equals -b over 2a and find the x-coordinate of the vertex. But here's another technique. It might speed you up a little bit, and that's completing the square. Okay, and it's really good when your b term is even, like it's a +6. It can be done, of course, if the b term is odd. It just goes really quick when the b term is even. So what I do to complete the square, complete the square, is I cut the b term in half, which is 6, and I square it. And I'm going to add 9 into that function. Okay, so I'm going to add 9, but then I'm going to subtract 9. It seems like it's illogical why you do that, but it'll become clear. If I put a 6x and add that 9 after the 6x, to keep it equivalent, I also have to subtract 9. Okay, plus 10. It looks strange, but you'll see why now. So now I'd have y equals x squared plus 6x plus 9, and then the last two numbers, -9 plus 10, is a +1. So we do that so we can do it's now that x squared plus 6x plus 9 is a perfect square trinomial, which means I can factor it very nicely. X plus 3 squared plus 1. Okay, so what does that mean? How is that different from this function, y equals x squared? Well, the plus 3 is grouped in with that x. That means it's a shift left or right. Okay, so it means take that basic parent function, y equals x squared, shift it left 3, and the plus 1 behind the parenthesis means shift it up 1. Okay, so I just take my my vertex, which would be at 0, 0. I'm going to shift it left 3 and up 1. So my vertex is at -3, 1. Now we could of course use the x equals -b over 2a. Okay, it works fine. Okay, in front of the x squared is a 1. So again, I can use this classic graphing technique. You know, right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. So I can graph it very quickly. Right 1, up 1, left 1, up 1, right 2 from the vertex, up 4. All right, symmetric. I can't right 3, up 9 will not fit. So here's my graph. Okay. All right. What are the characteristics? Okay, domain. Substitute any number I want, I'll get an answer. Okay, all real numbers. The range. Okay, my vertex. I always look for your vertex to find the range. Go over here to the y-axis, 1. Okay, it has something to do with 1. 1 is the lowest it goes, so I'll put a 1. Put a bracket there. Goes up forever. Interval of increase. Okay, I go from my vertex straight down to the x-axis, which is at -3. So from -3 to infinity, graph's going up. Okay, interval of decrease, negative infinity to negative 3. These two will always be, the same two numbers will be involved every time we're doing these kind of quadratics. X-intercept, now what's the x-intercepts? This U-shape, where does it touch the x-axis? Well, the U-shape is above the x-axis. So in this case, there's none. Quadratics, when we have a quadratic equation, we can have no x-intercepts, we can have one x-intercept, or we can have two. We can't have more than two. Alright, so this case, none. We're always going to have a y-intercept. Oh, on the graph, I can't really see where it would touch the y-axis. Don't guess. How do you find the y-intercept? You make x 0. Okay, so go up to the function. Y equals x squared plus 6x plus 10. You make x 0. So you see the x squared is going to be 0 to 6x. Y equals 10. It's going to be a little above our graph, but that's what it would be, 10. Alright, the right-hand behavior. Okay. This is an upward facing parabola. So as x approaches positive infinity, y approaches positive infinity. Let's get these off there. So as x approaches infinity, y approaches infinity. As x approaches negative infinity, y still goes infinity. Okay, you're always going to start out like that, always. X approaches positive infinity, x approaches negative infinity. Alright. Alright, I just want to finish up with just one more. Alright. Okay, so if you've been watching, when you see coefficient of 1 from the x squared term, I've been doing this quite often. Right 1, up 1. Left 1, up 1. Right 2, up 4. Left 2, up 4. Okay? Alright, I want you to know this one. You can do this really easy too. Y equals 2x squared goes like almost the same way. Okay, when you go right 1, if it was not a 2 in front of x squared, you go up 1, but we're going to take that 1 times 2 and say up 2. And if we go left 1, we go up 2. Okay, if we go right 2, we're going to square that and get a 4. 4 times 2 is 8. We're going to go up 8. If we go left 2, we also go up 8. So the graph will go simple like this. Y equals 2x squared, point at the origin. Instead of going up 1, you go up 2. Symmetric. Instead of going up 4, like usual, you go up 8. Okay? And simple as that. Alright, if it said y equals 3x squared, instead of going up 2, you go up 3. And you go right 2, you go up 3 times 4, you go up 12. So the larger the coefficient in front of x squared, alright, the steeper it's going to go up more quickly. Okay, so just to finish this up, characteristics, domain, all the numbers. See if you get the same thing I do. Range, 0 to infinity. Interval increase, 0 to infinity. Interval of decrease. Use parentheses there. X-intercept is 0. The y-intercept is 0. The right-hand behavior as x approaches infinity, y approaches infinity. As x approaches negative infinity, y also still approaches positive infinity. And that's it for quadratic. We can do a lot more, but that is the basics.